the 4, between the 4 and n, a predetermined amount of times. That is determined by the array on the right side of the for command. The array, whatever the array is, the loop will run for each element of the array. So if that's confusing to you, just always set your array up to go from 1 to some number, and whatever number that is how many times the loop will run.
Is there a special reason you need the brackets to make an array?
No, with the colon operator, the brackets can be removed. If you don't have the colon operator, then you need to put the brackets there. I just put them there to make it extra clear that that is an array, and that's the notation. The while loop, on the other hand, runs until a condition is true. So the only way a while loop makes sense is if there's some condition that's changing inside the loop. Otherwise, there would be no reason to write a while loop. And remember, you can always replace a for loop with a while loop by just doing a counter. We also talked about if statements for the past 2 topics. I feel like this is something that most people it's more intuitive than the loops. But basically, when you put an if, it checks the condition on the right side of the if statement. If you would like to check more than one condition, so here's a condition 1 and condition 2, you need to put an else if, same word. If you just put else, then the code in between else and n runs for any other condition other than the conditions that are above it. So you just have to kind of decide how you want to do that. It depends on the logic that you're doing. So I want to talk a little bit about memory allocation. I guess this should be topic 5. Sorry about that. Both of those should. So with memory allocation, I have just a little example, like a visual example that might help make this make more sense. So I'm going to be bothering some of you. Just come with me on this journey, okay? So we're defining an array. So method 3 is vector notation. So I'm defining an array. What are the values of the array? 2, 4, 6. So I want to define that array. I'm going to show you how to define it with a loop, and I'm going to show you what the code does with memory allocation and without memory allocation. Sorry, pre-allocation. So I guess I won't make you guys get up, but this is what it does. So I'm going to do the method 1 first. So what it does, what Matlab does without memory pre-allocation, is it starts going through the loop. So I equals 1, so it's going to set the first element of v. So what it does is Matlab is like, okay, we need to put this v somewhere. And it walks around and it finds a spot in memory. So here, I'm going to give Kyle v1. Now that's where v1 is held, right here in memory. Then it goes to I equals 2. And then now there's v1 which equals 2 and v2 which equals 4. So there's an array with 2 elements in it, right? So now, forget about Kyle. Who cares? I'm going to find a new spot. These 2 guys are going to hold the 2 spots in the array, 2 and 4. Okay? Then it happens one more time. Now the array has 3 spots, and then it goes and it searches, and it goes somewhere else where there's 3 spots. There's 3 spots right here that are open. I'm going to take these 3 spots. So these 3 people are holding the arrays. So it took 6 spots of memory to fill that array, but the array only has 3 spots. So method 2 is the code is like, okay, I'm going to pre-allocate v. I'm going to pre-allocate with zeros. These are my zeros, these 3. So I'm giving you the first element, you the second, you the third, but I'm putting zeros in there because I don't know what's going to go there yet. Then when the loop runs, v1 is 2. So I'm going to put 2 here. v2 is 4. I'm going to put 4 here. v3 is 6. I'm going to put 6 here. And so I only used 3 spots because I told it where to put it before I filled it. So if you don't pre-allocate and you have a lot of a big array, which we do, like at the end of the class we're going to be filling arrays with hundreds, thousands of elements. It's like factorial, of how much space it takes in memory. So it takes a long time for it to find those locations, but it also fills up the memory. So that's why you pre-allocate. Did you have a question?
Yeah, why doesn't it pre-allocate to begin with? Like if just realized, well, I've got this one vector here, then just add her array, just add another element.
Because it doesn't know. Computers just follow the rules. So it starts with the loop, I equals 1, and then all it knows is that I equals 1, you need 1 element. It doesn't know about the rest yet, because you haven't told it. So it just reads from top to bottom, and in a loop it reads the loop one at a time. So most programming languages, just so you know, do not allow you to not pre-allocate. Matlab is kind of special in that way. Like all the more fundamental languages like C, C++, Fortran, you can never fill an array until you pre-allocate it. So it's a very unusual problem to run into in a programming class. Do you guys have any other questions about that? Okay, so we've been doing a lot of array manipulation, and I wanted you to just see how you can do the same thing so many different ways, and so many different levels of, like the first one takes so much typing, and the last one takes so little typing. So in this example I have for you, I have an array, and it's just a 2D array that the first row is 1 through 3, and the second row is 4 through 6. And I want you to multiply the top row by the bottom row, and then take the mean of all of those. So the bottom way, I just did it all using vectors. I multiplied the top row by the bottom row using the dot operator, and then I took the mean. And it just did it in one line. The top one, I individually multiplied each element by each other, and then I individually averaged them. And then the rest in between are just other options. So I don't mind you actually doing things the long way if that's what makes sense to you at that point. I would much rather you take out and pull out elements and actually you understand what you're doing than do it this shortened way and not understand what it's doing, okay? So just know that you can break it up however you would like when you do any of these operations. And hopefully at some point you can see that there is a faster way to do some of these things, but it's more important that you kind of understand what you're doing. Okay, so I'm gonna move over to the doc cam and we're gonna start the topic on functions today. Exciting topic because we've been using functions all semester. We've been using the functions, but we've never talked about what a function is, so it's kind of funny. But you can use Matlab, it's pretty user-friendly to use, even without knowing what it's doing. And so we've been using all of these functions without actually understanding what functions are, what inputs are, how functions are set up. And so we're first going to understand how functions work in this topic, but then the exciting part is we're going to write our own functions now. So max, for example, that's a function. You can actually go find, we used to be able to, they actually hid them all now, but there's an M file somewhere called max, and it's just a function, and you could write the same function yourself. So that's the goal of this topic, is to understand how they work, and then to also start writing our own. So far, we've been writing Matlab codes, but they're called scripts, script files, and you've probably seen it when you've opened one up. It has the .m extension, and so does a function file, but a Matlab script does not read in any inputs or output any outputs. So a script is, we run scripts so that we can put in a list of commands that are run all at the same time rather than in the command window entering in commands one at a time. So now what we're going to talk about is writing Matlab functions. And Matlab functions are actually an option in Matlab when you open up a new script file. So just let me show you really quick, and then we'll talk a little bit about them. When you click New Script, this button here, which is what most people do, it automatically opens up a script file. If you click on the button next to it, the down arrow, you'll see that you can write a live script, a function, an example, a class, a system object. We're actually not doing anything in this class but a function and a script. And when you open up that function, you'll see that it will give you a wrapper. And the basic idea of the wrapper is that you have the name of the function here, you list your inputs here and your outputs here, and that's sort of what we're going to be talking about. However, you don't have to use, there's nothing special about this file that's created. You can just create a script file, so you can turn any of your scripts into functions, and you can just create your own inputs and outputs just like you saw in the default. It's just creating that wrapper for you. So there's nothing particularly special about the file type of a function. It's just the purpose is different and it has additional functionality. So the definition of a function in Matlab is it's a script file that allows for inputs and outputs. And you've sort of experimented a little bit with inputs through the user prompt input, but user prompts are so annoying. I would never use them in a code. They can be convenient for like certain special applications, but having something prompt and not run until something is entered in is actually very obnoxious. So function inputs are a little bit different in that they allow you to send information in and out of a function file so basically that you can run the same thing with a different number. So I'll show you a little bit about that. The way that you set up a function file is with a function declaration line. And that's what I just showed you here, that automatically gets filled when you open up a new function. So the way that it works is you write the word function and it will turn blue, and that makes it so that it is automatically recognizing this file as something that's going to have inputs and outputs. You list the outputs, and you can have as many outputs as you want. You can have 0 outputs, you can have 1 output, you can have 2 outputs, or you can have 1,000,000 outputs. Actually, there's probably a limit, I don't know what it is. But you can have as many as you want. The outputs can be arrays, they can be values, they can be strings. You put in an equal sign with the name of the function, which also needs to be the name of the file. And in parentheses, behind the function name, you put in inputs. Inputs are in parentheses, outputs are in square brackets, and each individual one is separated by a comma. You should always start your function. This is, if you look at any Matlab written functions, they're all written this way. You need to tell the user what the outputs and inputs are for the function. And when we've used functions, this is something you always have to look up when you use a function in Matlab. If you use the max function, you need to see what functions or what outputs are even available in that function. Then you're going to list all the commands that execute your code, whatever they are. And then you need to close the file or the function with an end. Sorry. Keep in mind that this function name needs to be the same as the file name. And I'll show you that. And let's just talk about a couple of the rules. So for outputs, they have to be in square brackets. When you set up the function, the only way the function will work is if those outputs are in square brackets, even if there's only one of them. And you can have 0, 1, or many. So you can actually write a function that doesn't have any outputs. That's okay, and we do that all the time. Now the inputs, there has to be parentheses, and then same thing. You can have 0, 1, or many. So you can have a function that has no inputs, and there is still a reason that you would have that. I actually never write code outside of a function. All my code's always in a function. It keeps stuff contained, and it makes it so you can call on specific things that you repeat a lot instead of retyping it or copy and pasting it. There's a huge difference between functions, and when the quiz happens for this thing, I swear to you, I'm telling you, I'm saying this right now, okay? Record this. Look at this. Watch this again. Everyone listening, this is important. Functions are black boxes, which means whatever goes in, something comes out, but you don't know what happens on the inside. So what that means is when you call a function, the variables inside that function do not go to the workspace. So when you put something in a function and you run it in Matlab, all those variables you define in the function used to show up in your script file in the workspace so you could kind of like test things out. They will not. So if you're debugging, you can comment out the function declaration line if you would like, so that you can see as you're coding what the code knows about. But when you ultimately start running your file, nothing's going to show up in the workspace. So you're going to have to do more tricks to show you what's going on, basically. So I'm going to move over to Matlab and show you some functions that you've already used and how they work. So, intrinsic functions are functions that Matlab wrote, that Matlab comes with, and we've been using them like crazy. So, let's say I have an array of values. If I plug that into the max function, the input to the max function is v, and the output is the maximum value. So when I need to run a function, the function doesn't work. So max is a script file. It doesn't work if you do not provide it the inputs. Inputs are mandatory. So if you don't give the function something to read in, basically that variable that it's using inside of the function is unknown, and so none of the code will execute properly. If you give it the input, it works. The outputs, on the other hand, are optional. So you can see here that I didn't give it any output to go to. I just let it print a screen. But we've used the max function lots of times, and we would give it one output. And so if you go to the help, you see that one output, the first one in the max function, is the max value, right? But you could also give it two outputs. So this is the max value, A, the first output. What's the second output? It's its location. So that's intrinsic to this max function. That's how someone wrote this max function. So if you go in and look, you can see all these options that you can just give it an input, you can give it an input and two outputs. Sometimes Matlab functions allow you to give additional inputs that are optional, but all functions that are written in Matlab that we use, almost all of them require one input. There's a few examples. Has anyone ever showed you some of the weird things in Matlab? Child, what is it? Boy, little boy? There's all these little like weird things that you can type in that do different things, like y is one. So if you type y, it's a function, but it has no inputs, and it just prints out some random statement. I think it changes every time you do it. So it doesn't require an input, but it's a function that's being executed, okay? And there's actually quite a few like that you can run that don't have inputs. But for the most part, if you're running something that has some use, it needs an input, right? Like max or sign or find or any of those functions need something to be calculated. Another function that you've seen before that you've used the two optional inputs is kind of confusing because the function name is input. So it gets a little bit confusing because I think your first function assignment uses this function. But I'm calling the function input. I'm giving it the first input as a string, and then it optionally, or then it asks for the name, and I didn't give it an output. But you've seen before that there's a second input that you can add, which is the S, and the S means what? That means that the user is going to put in a string. So that second input was optional, right? And then you can also run that, and you can give it an output, which just saves the resulting response from the input prompt to the value m. So now m has the response from the user. So that's kind of like just connecting functions to intrinsic functions, which you've used before. So now what I want to talk about is user-defined functions. User meaning you, meaning not intrinsic. So that's what we're going to be doing, is writing our own Matlab functions. So I'm just going to write a few different ones. So the first function is going to be really simple. I'm going to write a function that defines the following array f. So I have this function f that depends on x. And I want to write a function that basically defines this value for any x value. So this example is going to have one input and one output. So to do that, I'm going to create a new script. I'm going to type the word function, and I'm going to close the function with an end. I'm going to first name my function. So I'm going to name it defineF. That's the name of the function. That's also the name that I want the file to be. So if you do a save as, it will automatically recommend that you use the file name. Oh, wow. I'm not very creative because I've already written this function. DefineF, and so now you can see that the file name and the function name are the same. I'm going to create an input, and I'm going to call the input x, and an output that I'm going to call f. Inside the function, I'm going to just write out that equation that I just wrote on the screen. So my first run of this function, I'm just going to allow the user to enter one value for x. I'm going to do the calculation and output the value of f for that x. So that's the whole function. It only has one command in it. I'm going to go into my command window, and I'm going to start typing the name. So I'm in the folder that I stored it, just like you have to be with your script files. I'm going to let it autofill. So that's not the name of mine. DefineF. So see, my function name shows up as an option. You can click on it, or you can just type it out. And I want to see, well, let's first just run it. So if I run it, and I don't put any inputs, I just run the file like you're used to, you'll see that you get not enough input arguments. That's because in the function, the command on the right-hand side of the equal sign says that it needs an x. And there's no x defined in the command, it's only defined as an input. So, it throws an error. Let's say I hard-coded it and I didn't even use the input, and I pressed run. It doesn't have an error anymore, because the only problem it has is that it's using something that needs to be provided by the input. But if you define that in the function, it actually is fine with it. If you take that out and you try to run it, you'll always get this error. New in Matlab 16, it actually allows you to use the run command with an input. So I can actually put in my input when I press run and run it from here. That's a really kind of clunky way to do it because you have to keep clicking in there every time. It's much easier to just go into the command window and edit the input manually. So the function for x equals 1 is 0. you'll notice that I don't have to give an output, but I could. So I could say f of 1 equals define f at 1. So that's optional. So now, what if I wanted to find an x value? So I'm going to define an x with a few different values, and then I go in and I type my function and I plug in my whole array of x values. I get an error. Does anyone know why I'm getting this error? Yeah, so the way I wrote this, I only allowed the user to put a single number in because I didn't use element by element notation. But if I simply put a dot before the power, then when I go to run it, it will find the f value for all the x values. So that's a basic function. Now I want to talk a little bit about how you can call functions from other functions. So I'm going to open up a new file, and you're doing this in your lab. You're going to be writing functions and calling them. You actually write your first part you just write a function, and then your second part you write 3 different functions and they call each other. So there's a couple different ways you can do that. So I'm going to create a second function, not being very creative with my names. And inside this function, these 2 functions are in the same folder, so they can call each other. Does that work actually? Oh, that didn't used to work. So I'm going to call define f inside this other function. So I have this function that's calling the one I wrote over here. So in order to run this, you actually have to run this file. It calls define f, and I have it unsuppressed, so you can actually see that it called second function here, and it reported back 0 that it calculated from plugging in x equals 1. So why would you ever do that? Well, you could create a for loop, for example, that plugged in a bunch of different values into a function. And so let's say you needed to do the same thing 100 times. You needed to call a function. You could set up a loop that runs through all the x values and then plugs each x value in one at a time, and then define the output to some other array. And then at the end, you could see what it looks like. So this function is going to run the define f function 100 times, save the output f's to the array f, and then it's going to plot it. Maybe, there's probably a problem. Okay, and so that's what it looks like. And so this is a really, really useful way to clean up your code by putting stuff in subfunctions and calling those subfunctions. It's kind of like, it kind of simplifies a lot of the debugging when you do stuff like this. Now, define f is a black box. I told you that before. So this function, second function, knows nothing about what happens inside. All it knows is what it put in and what it got out. So it actually doesn't know what the x and f variables are here. So it doesn't know what x is and it doesn't know what f is. So let's say that I had some variable defined in here that was like a coefficient to one of these. So I had an alpha, some alpha coefficient that multiplied by the quadratic term. And then I called that function, and then I was like, actually, I would like to know what the alpha is. It has no idea what alpha is. Only that define f function knows what alpha is. So it's easy to get mixed up about what it knows and what it doesn't know with functions. Yeah?
Is there any way to like call that variable from define f?
So the best way to do it is if you did need a variable out, you'd throw it back as an output. So I added alpha to my output list, and then when I call it here, I include it as an output, and then it will know about it. So there was no error. I didn't do anything with alpha, but you'll see that it prints. The other option is the next thing I wanted to show you, which is right now I've showed you how to put functions in different files, but you actually don't have to have a function in an individual file. You can put multiple functions in a single file, which is what you normally do. And what you're going to be doing on every quiz from quiz 6 and beyond. You can only submit one file, so you need to know how to properly put your functions in a single file. So the way you would do that is I have this define f function. I'm going to copy it, and I'm going to move it to the bottom of this file. So what Matlab does is if you call a function, it's going to check your file first to see if there's any function with that name. If it doesn't find one, then it will go out and find any in the folder. And so this one will overwrite the one that we wrote in the other file. And this way they're all in one place. You can see them all. It's very unusual in this class that we'll be writing a function that we need in multiple assignments. But it's really nice when you're doing other classes, like for example, you write a root finder. You would want that root finder to be its own file so that you can use it whenever you want. I can't call this define function anywhere else. I can't call it in any other place other than this function. So I'm going to go into my current folder where I wrote that first function, and I'm going to delete that file. So now do you see I don't have the define f function anymore in the folder? The define f function is only in this file. So if I try to call define f, it doesn't know what define f is. It only knows what functions are based off of their file name. However, if it's in the same file, it doesn't have a problem. So this will run just as normal because the function is defined down here. So one thing that you can do if you have functions listed in the same file is you can start creating global variables. So you can say that alpha is a global variable, so wherever it's defined, all functions know about it. So then you don't have to send it as an output in the define f function. Maybe. It should be actually blue, but it doesn't create an error. So you must need to define it here, and then it will know about it here. I'm not exactly sure where you have to define it, but you can see that it knows that alpha is a global, but it's not recognizing it here. I know if this is nested, it does recognize it, so now this function is nested inside of the external function. That always makes it so it knows about each other, but that's actually a really bad thing to do in general. You don't usually want to nest functions because then your variable names can get messed up. So in the pre-lab, you're going to be doing a lot of functions, and then in your lab, you're going to be writing two totally separate functions again. I'm just telling you that at least half of you will come to me with lab 1, and you will run that file, and you will be like, it's not working. And you know why it's not going to work? Because you didn't put in inputs. So if that happens to you, I'm telling you right now that I'm going to remind you of this moment where I said, all of your functions will have inputs, and they won't run if you don't give them inputs, okay? They won't work. You can't press run anymore. You have to put in the inputs.
3 hours.